If you think you've already heard everything there is to know about 3I/ATLAS, think again, because the universe just raised the stakes. The third interstellar object ever detected in our solar system is no longer just a curiosity drifting through our cosmic backyard. It is rapidly becoming one of the most unpredictable, most active, and most confusing visitors astronomers have ever tracked. And right now, telescopes across Earth and in orbit are capturing behavior no comet, interstellar or not, has ever shown before. It began quietly enough. In early July 2025, the Atlas Survey telescope identified a faint moving speck in the sky. At first, researchers thought it might be just another long-period comet making its return trip into the inner solar system. But then its velocity told a different story. Only objects from deep interstellar space move this fast. Only objects that were born around another star carry this kind of energy, and only interstellar travelers arrive without warning, cutting through our solar system on a one-time trajectory, never to return. That alone would make 3I/ATLAS historic. But what happened next pushed this comet into an entirely different category. As astronomers gathered early data, they noticed something off. The brightness didn't match the distance. The coma was forming too early. The outgassing was too intense for an object still far from the sun. Within days it became clear 3I/ATLAS was unusually active, far more active than any comet we've seen outside the inner solar system. Then Hubble turned its gaze on the visitor, and the mystery deepened. The nucleus wasn't large and dark like early estimates suggested. Instead, it appeared smaller, sharper, and surrounded by an abnormally energetic halo of dust accelerating in multiple directions. The teardrop coma wasn't just reacting to sunlight. Something inside the object seemed to be driving the activity. Something volatile, something ancient, something we've never seen up close. That was the moment astronomers realized they weren't simply observing a comet. They were witnessing a relic from a completely different planetary system, one that doesn't play by the rules. As the days passed, more observatories jumped into action, and the strangeness surrounding 3I/ATLAS only intensified. NASA's TESS spacecraft, built to hunt exoplanets, not comets, unexpectedly became one of the first telescopes to capture the object long before anyone realized what it was. And when astronomers dug into that archived data, they found something no comet expert could easily explain. Based on the object's changing distance from the sun, scientists predicted a mild increase in brightness, maybe a factor of 1.5. Just the usual warming and slow sublimation that happens as icy bodies approach the inner solar system. Instead, 3I/ATLAS brightened 5 times more than expected. 5 times. That level of activity doesn't happen at that distance. Not from water ice, not from carbon compounds. To produce such energy, the comet must contain extremely volatile materials, substances that evaporate under the faintest touch of sunlight. Hydrogen, nitrogen, exotic ices. The stuff that normally exists only in the frozen outskirts of distant star systems. Suddenly, the idea that this object had traveled billions of years through interstellar space didn't just seem likely, it seemed undeniable. But the brightness surge was only the first clue. When researchers tried extracting a light curve using TESS images, the results were even stranger. Most comets produce a jagged pattern as sunlight glints off their irregular tumbling surfaces. But 3I/ATLAS showed an unusually flat curve, as if the object wasn't rotating the way comets usually do, or as if its surface was covered in a layer of dust so uniform, so fine, that it smoothed out any reflective variation. That kind of surface doesn't fit with typical comet models. And that wasn't all. Ground-based telescopes, including Gemini South, began detecting a tail far longer than earlier images suggested, proof that whatever was happening inside 3I/ATLAS was accelerating. Cyanide signatures grew stronger. Dust jets shifted direction. And then came the most alarming detail. Some dust was flowing toward the sun, not away from it. Comets don't do that. But this one did, and every new measurement pointed to the same conclusion. 3I/ATLAS is not behaving like anything we've observed before. But the most shocking revelations came when astronomers studied how 3I/ATLAS scatters and polarizes light, a technique that reveals the hidden physics of dust grains, surface texture, and internal composition. And what they found has no parallel in any comet ever observed. A global team analyzing data from Chile, Bulgaria, and the Canary Islands detected an exceptionally deep, narrow negative polarization branch, a behavior so extreme that it placed 3I/ATLAS in a category of its own. Most comets show mild positive polarization, or at worst, a shallow negative dip. But this was something entirely different. It meant the dust around the object was forcing incoming sunlight to align almost perfectly parallel to the sun-comet direction. That simply does not happen unless the dust grains are shaped, sized, or structured in a way we have never documented in the solar system. Even Borisov, the only other interstellar comet we've seen up close, didn't behave like this. Whatever built 3I/ATLAS, the star system it was born in, the collisions it endured, the environment it formed in, was fundamentally unlike anything that exists around our sun. And then came the next twist. During a lunar eclipse in September, 2 amateur astronomers in Namibia captured images of 3I/ATLAS, glowing with a faint green hue. Normally, this color only appears when comets release diatomic carbon, which fluoresces under sunlight. But 3I/ATLAS had already been classified as highly carbon chain depleted. In simple terms, it shouldn't have enough C2 to glow green, so either the comet suddenly exposed deeper layers rich in trapped molecules, or it just began producing carbon compounds in a way no one anticipated. Both possibilities point toward dramatic internal changes as it approaches the sun, and that's where things get even more intense. Interstellar objects endure unimaginable radiation, collisions, and gravitational stress across billions of years. Many fall apart long before reaching another star. 3I/ATLAS could easily do the same. If its fragile nucleus fractures, it could unleash a violent burst of activity, revealing ices, gases, and materials that have been sealed away since before our solar system existed. And because this object is moving fast, any breakup would be explosive, rapid, and scientifically priceless. As if the scientific discoveries weren't already wild enough, the story of 3I/ATLAS took a new turn when controversial astrophysicist Avi Loeb entered the conversation. He pointed to early size estimates, nearly 10 kilometers across, and argued that such a massive interstellar object should be unbelievably rare, too rare in his view to be purely natural. And from there, he proposed a far more dramatic possibility, that 3I/ATLAS might not be a comet at all, but some form of alien technology. But as updated Hubble measurements shrank the nucleus to 5.6 kilometers or less, many of those early concerns faded. The unnatural size argument dissolved. And yet, the public attention it generated pushed the comet back into headlines worldwide. Meanwhile, other scientists countered Loeb's claims by analyzing the comet's trajectory using newer orbital solutions. They found no evidence of maneuvers, propulsion, or engineered motion, just natural dynamics influenced by intense outgassing. Still, the discussion highlighted an uncomfortable truth. Even if 3I/ATLAS is entirely natural, it behaves differently enough to force astronomers to question long-held assumptions about interstellar visitors. And now, as the comet races toward perihelion, its closest approach to the sun, every major observatory capable of tracking it is preparing for what comes next. Will its activity explode as sunlight hits fresh layers of volatile ice? Will the nucleus crack open, revealing materials older than our solar system itself? Or will it survive intact and offer a rare, continuous look at a messenger from another star? NASA's SOHO might capture it during its closest approach. JWST and Hubble will observe whenever geometry allows. Ground-based giants like Gemini, VLT, and Subaru are coordinating high-resolution campaigns. Every telescope, every spectrograph, every snapshot could reveal something groundbreaking. Because if 3I/ATLAS breaks apart, we may witness the first real-time destruction of an interstellar visitor. And if it survives, we'll gain months of unprecedented data from a body shaped by conditions no human has ever studied directly. Either way, the universe has handed us a mystery that refuses to behave, refuses to fit the rules, and refuses to be ignored. 3I/ATLAS is getting stranger by the day, and the real discoveries haven't even begun. Gotovo.